Okay, welcome to lesson 6.2 on radian measure and angles on the Cartesian plane. We're going to start with a summary of the trig ratios for the acute special angles in simplest form. So I am going to change those so that they don't have any roots in the denominator. So the first angle we're going to look at is pi by 4, which you might remember is the same as 45 degrees. So I'm thinking about my special triangle for pi by 4, and that's the excuse my terrible drawing here. That's the 1, 1, root 2 triangle, right? This is my pi by 4 triangle, and so there's pi by 4 in each corner. So the opposite and the adjacent are both 1 in this triangle. When I think about sine of pi by 4, I'm thinking about the opposite over the hypotenuse, so it's going to be 1 over root 2. But instead of 1 over root 2, I'm going to change that into simplest form. So I multiply the top and the bottom by root 2, just like we did in the warm-up yesterday. And then I get root 2 over, and on the bottom I get root 2 times root 2, which is root 4, or the square root of 4 is just 2. So the sine of pi by 4 is root 2 over 2. Last year we just called it 1 over root 2. For cos of theta, it's the same thing because it doesn't matter which corner I'm looking at. So let's say I was looking at pi by 4 as being this angle down here, then the opposite is 1, but the adjacent's also 1. So I also get 1 over root 2, which is the same as root 2 over 2. And then for tan of theta, again, doesn't matter which corner you take a look at, tan is the opposite over the adjacent, so it's just 1 over 1, which reduces to just 1. All right, next we're going to take a look at our pi by 6 and our pi by 3. So pi by 6 means I'm taking pi and I'm cutting it into, I'm going to redraw this triangle so it actually looks like the angles are two different sizes. Pi by 6, I'm taking the pi, the top half of the circle, and I'm cutting it into 6 wedges. So I'm cutting it into smaller wedges. Here I'm just taking the top of the circle pi and I'm dividing it into 3 wedges. So that means that they're going to be bigger wedges here and smaller wedges here. Pi by 6 is the smaller angle. Let's see if I can squeeze it in here. And pi by 3 is the bigger angle. So pi by 6 is the smallest angle in the triangle. You might remember too that 90 degrees in the corner here, the right angle, is pi by 2. It's the biggest angle in the triangle. It helps me remember that the hypotenuse 2 is the biggest side. It's across from the biggest angle. So that's 2. Across from pi by 6 is 1. And if you're not remembering this special triangle, you want to go back and take a look at lesson 6.0, where we reviewed the special triangles from grade 11. And then the middle angle, the middle size angle, is going to be across from pi by 3. And it's kind of nice, this one, for memory purposes. Pi by 3 matches up with root 3. And so those guys go together. And then across from pi by 6 is the smallest. We're going to have the smallest side. And so this is going to help me come up with my ratios for sine of pi by 6. I'm thinking about the opposite of pi by 6, 1 over the hypotenuse 2. For cos of pi by 6, I'm looking at my adjacent side, root 3, over the hypotenuse 2. And then for my for tan, I'm looking at the opposite over the adjacent. So tan is coming out as 1 over root 3. We know that we're not allowed to have those square roots in the denominator anymore, so I'm going to multiply that by root 3 over root 3. Just multiplying by 1 here doesn't change anything. It's just going to change the format. So I multiply the numerators together, I get root 3, and multiplying the denominators together, I get root 3 times root 3, which is root 9, and I know that the square root of 9 is 3. So tan of pi by 6 is root 3 over 3. And then pi by 3, I'm going to switch corners, and we're taking a look at this corner down here now. For sine of pi by 3, I want the opposite, root 3 over 2. And then for the cosine, I want the adjacent 1 over the hypotenuse 2. And then for tan of pi by 3, I want the opposite, root 3 over 1. And root 3 over 1 is just the same as root 3. All right, moving on to the example 1. Example 1 is when I'm given the angle and they ask me to find the ratio. So they're always going to tell me which ratio to find, sine, cos, or tan. Sometimes they'll throw in a reciprocal ratio, like cosecant, secant, or cotangent. But they're going to tell me which ratio, and then they're going to give me the angle. And my job is to actually find the answer, which is the ratio of the side lengths opposite hypotenuse and adjacent. So the first thing I'm going to do with this question where they ask me to find the exact value of each trig ratio, I'm always going to start by drawing a diagram. And you're going to find that this is usually your first step in almost every question. Just start by drawing a picture. So I'm going to draw my 4 quadrants, and then I'm going to, from here, I'm going to try and figure out where is 5 pi by 3 because I want to draw a picture of this. So remember that the denominator 3 tells me how many sections to cut this picture into. So I'm just going to thin this out for my picture. It's saying take the top and cut it into 3 wedges. So I'm going to have 1, 2, and I'm not doing a perfect job here. I'm not like measuring this with a protractor or anything. Oops, it scrolled on me. Oh. So I've got 1, got 2, 3, 4, 5, and 6. So I've got 3 wedges on the top and 3 wedges on the bottom. And then to figure out where 5 pi by 3 is, and really this is the only terminal arm you need to draw in, I'm just going around to the 5th of those arms. So I'm going to go all the way around to here, and this would be my 5 pi by 3. I'll just label that. Now the next thing I'm going to do is take that terminal arm, the last terminal arm that I ended up with, and I'm going to connect it to the x-axis. I always connect to the x-axis to create a 90-degree triangle. And what I need to know is what is this related acute angle in there? I'm going to call it beta. I always use beta for my related acute angle. So the first thing I'm going to do is state the second thing, drawing the picture and then stating my related acute angle. So remember, I've cut the triangle into wedges that are all pi by 3 in size. I've counted out 5 of those pi by 3 sections, and you can see there's only 1 left over. Beta is the size of 1 pi by 3 section. So beta is pi by 3. Now, using that related acute angle beta, I'm actually going to figure out the ratio just for that angle. So just looking inside that 90-degree triangle there. So I'm going to use tan because that's what was given to me in the question, and I'm going to do tan of beta. So tan of pi by 3. And I'm going to figure this out using my special triangles. So I know that for pi by 3, across from pi by 3, if I'm redrawing this triangle, I have root 3. And adjacent to pi by 3, I'm going to have 1, and then the hypotenuse is going to be 2. So I've got my side lengths there. I'm looking for tan, so I'm looking for the opposite over the adjacent. So I'm looking for root 3 over 1, or just root 3. Now my last step for part 1 here is to figure out, well, what is tan of the actual angle? We did the related acute angle. And in order to figure that out, I know it's always going to be root 3, but now my job is to decide which sign is it. Is it positive or negative? So that's my big job now. And in order to do that, what we normally do is come over here to the diagram and label out our cast rule. So remember, the cast rule actually starts in the quadrant 4, and then I'm going to count around into quadrant 1, 2, and 3. So if you don't remember your quadrant numbers, you should review that. We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Some of the questions will tell you which quadrant the angle is in, so you need to know those quadrant numbers. And so when I look at this diagram, I see that I'm in quadrant C here with my terminal arm, and C tells me that only the cosine ratio is positive in this quadrant. So since I'm looking at tan, it must be negative. And I do want you to tell me that you've decided that somehow. So let's say I did end up, maybe I was looking at cos of 5 pi by 3. Then the answer would end up being positive, but somehow you need to indicate that you thought about it. You didn't just forget and not write anything at all. So I've indicated here in a couple of different ways that I've thought about it. I've indicated by actually labeling cast on my diagram, and I've also indicated by just writing this here in rough that I had to decide whether it was positive or negative. And then we're going to move on to part 2. Part 2 says, state an equivalent expression in terms of the related acute angle. And a lot of people just struggle to understand what this question is even asking for. This question is asking you to use the same ratio that was given. So use the same ratio, but use the acute angle instead. And again, you just have to decide if they're positive or negative with each other. So I'm going to start with my original question, tan of 5 pi by 3. And it says state an equivalent expression, so an equal expression, yeah, in terms of the related acute angle. So I have to use that related acute angle pi by 3. And in order to do this, you're going to use the same ratio, tan, because it gets really complicated if you don't. And then all you have to do, again, is decide whether it's positive or negative. And here we've already decided that over here. I know that when I looked at my related acute angle beta, that the ratio came out as positive, and that when I looked at the actual angle 5 pi by 3, the ratio came out as negative. So in order to make these two answers equal, I would have to take the related acute angle ratio and make it negative. All right, moving on to the next example, sine of 3 pi by 4. Again, we're going to start the same way. We're going to draw a quick picture of this. Ooh, I'll use my line tool. So drawing my picture, this time I'm cutting my diagram into 4 pieces on the top and 4 pieces on the bottom. Now, like I said before, you don't have to draw out all those terminal arms. I did in the first example just to kind of show you my thinking. But all I would really do each time is draw the one that I care about. So here I want to put 4 sections on the top, but I'm going to the 3rd section. So I'm going to imagine cutting the top into quarters. So I would have 1 quarter, 2 quarters, and then 3 quarters is the one that I care about. So there it is there. And then I can just label my, my angle. So there's my angle theta, 3 pi by 4. And then again, my first job is going to be to figure out what is this beta angle in here. And then we'll create a 90-degree triangle by taking that terminal arm, dropping it to the x-axis. And there we're going to have our special triangle. I know it's going to be a special triangle because this question, I forgot to mention this, this question talks about determining the exact value. So whenever it asks you about exact values, what they're asking you to do is figure out, is to use special triangles and no decimals. All right. So coming back here, I've got my angle labeled. I need to figure out what my beta is. Again, there were going to be 4 sections on the top, and so I've counted around 3 of them. That means that there's 1 left here, and the section is pi by 4 big, so there's a 1 pi by 4 for my beta. I actually think it's almost easier to find the beta in radians than it is in degrees. So I've got my beta. I'm going to label the sides of my triangle. Now that I know it's a pi by 4 triangle, that's my 1, 1, root 2 triangle. And so then I know that sine of pi by 4, that's the opposite one over the adjacent, the opposite one over the hypotenuse root 2. So we've got 1 over root 2, but we know that we always change that into simplest form, which is root 2 over 2. And now I'm going to figure out, well, what about sine of the actual angle, 3 pi by 4? And so for 3 pi by 4, it's going to be the same number, root 2 over 2, and then my job is to just figure out, is it positive or negative? So again, I'm going to show my thinking. I'm going to label the cast on the diagram. And what I noticed is this time the terminal arm ended up in the S quadrant, which tells me that the sine ratio is positive. So I'm going to put the plus here just to make sure that I'm showing my thinking. I did think about this, and I do know that it's positive. So that's the end of part 1. And then moving on to part 2. Usually these would be asked as 2 separate questions in your homework, so you wouldn't have this work already here. But what you're going to do is come up with an equivalent expression for what you already have. So I know that the ratio is sine, so I already know that sine is going to be there. Now my job is to figure out what is the sine, and what is their beta, right? Those are my two things that I need to do. So it's kind of nice we've already got the beta over here, but sometimes you wouldn't have done this work already. To find the beta, there's a couple of different strategies. I think drawing the picture is probably the easiest, so you might want to do that as well. But some people can figure it out in different ways. Make sure that you show your thinking. I would draw this picture here and count around the 3 pi by 4s, and then you know that there's going to be one more to finish up the 4 sections in the top of the circle. So we've got a pi by 4 here. And then we have to figure out the sign. So again, you're going to show me that you thought about this. I should either see a plus or a minus here to show me that you thought about it. Again, the picture is going to help you see that it's in the sign quadrant, so plus. So make sure, again, you show me your thinking somehow. I think the diagram is the easiest way. All right, on the next page, we're going to look at an example where I'm given the ratio this time, and I have to find the angle. So this time, I don't know what the theta is. It's the mystery, but I've been given that the ratio is root 2 over 2. And then, of course, they're always going to tell you what the trig ratio is that you're looking for, whether it's sine, cos, tan, or maybe one of the reciprocal ratios. So for each of the following ratios, determine the radian value of theta, and we're limiting the value of theta to be somewhere between 0 and 2 pi. So you're not like looping around the circle like 6 times and ending up at like 11 pi or something like that. We're just looking at that first rotation around the circle. So the first thing I'm going to do, and in italics here for each of these examples, I've just written out kind of the steps. This would normally not be included with the instructions of the question. So my first step here is to draw the diagram with 2 terminal arms. So why 2 terminal arms? We'll draw a picture here. And so what I know here is that I'm looking at cos of theta, and I also know that the ratio is positive root 2 over 2. So that positive is important. It's telling me where this angle lives. Remember that I can label the cast rule. It's kind of like we're going in opposite order here, right? First we thought about the sign, whether it was positive or negative. Then we thought about the cast rule, and then this tells me where to draw the terminal arms for these angles. So I know that the cosine ratio is positive. So that tells me that it's either in the A quadrant or it's in the C quadrant. Now I don't really care about the angle that you put this line on. So if somebody else drew this line like this, or maybe they swung it out here, I'm not as concerned. What I'm concerned about is that you ended up in the right quadrant so that you're drawing your picture correctly. After we've drawn our diagram with our 2 terminal arms, the next thing we're going to do is find our related acute angle beta. So to do that, we're going to think about our special triangles. Okay, so I know that the cosine ratio is root 2 over 2. So I'm thinking about my special triangles and I'm trying to figure out, well, which triangle is that? If it's got a root 2 in it, it's got to be the pi by 4 triangle, the 1, 1, root 2 triangle. So I know that beta has to be pi by 4. There's only one angle in that triangle other than the right angle. So I know beta is pi by 4. So the next thing that I need to do is I've got my pi by 4 in here. And I've got my pi by 4 in here. So the next thing I need to do is figure out, well, what are the 2 angles? There are 2 angles. The first one, ending at this terminal arm, is theta 1. And so notice I'm using a subscript of 1 on my theta. And then the second one is starting again at the positive x-axis, but this time rotating all the way around to that second terminal arm. And this one is theta 2. So now I can actually calculate, well, what is theta 1? Theta 1's really nice when you end up with one in the A quadrant or the first quadrant. Here my angle is the same as beta. And then for theta 2, make sure you tell me that you know that though, right? That theta 1 is the same as pi by 4. And then theta 2, I need to figure out, well, how big is this one? So here's where I want to think about, well, how many sections did I cut the top into? That one, remember, I'm doing pi by 4, so there's 4 sections on the top, and then there's 4 sections on the bottom. And all we're missing is one section. So if there's 4 sections on top, 4 sections on the bottom, that's 8 sections in total, and I'm just missing 1. So I have 7 of the pi by 4 sections. So I have 7 pi by 4. And we're done. So we're moving on to example 2. Example 2 a little bit different because it starts off with cosecant of theta. So we're starting right away with a reciprocal ratio. We're going to change that into its matching primary ratio. So the cosecant goes with sine, and so I'm just going to do the reciprocal of -2, which is -1/2. So I'm just flipping it over, right? This is 2 over 1, flip it, make it 1/2. And then I'm going to draw my picture. I'm going to figure out which quadrant am I in. So remembering here that I have sine of theta is negative. So my cast rule, because I'm showing my thinking. And then I'll add my terminal arms. So if the sine ratio is negative, I can't be in the S quadrant because it's positive there, and I can't be in the A quadrant because it's positive there. I must be in the C and the T. And again, I don't really care what angle you put this on as long as you're in the right quadrant. Next, I'm going to think about, well, what is my beta angle? So this is, again, I'm going back to my special triangles, and I'm thinking about, okay, my ratio is 1 over 2. And I might draw this into my picture to try and help me remember. So I know that to come up with these, and you can do it in either quadrant. I could have done it over here. I know that to come up with beta, that the sine is 1 over 2. So the opposite is 1, and the hypotenuse, remember sine is opposite over hypotenuse. The hypotenuse is 2. So this is my 1, 2, root 3 triangle. And I just have to figure out, well, is it pi by 6 or is it pi by 3? So remembering that across from root 3 is the pi by 3, right? They partner up. And then across from 1 is the smallest angle. So that means I'm taking pi and I'm cutting it into the most number of sections to make them the smallest sections. So that's pi by 6. So my beta is pi by 6. All right, so my next, so remember I've got 2 possible angles, and I'm going to label them on my picture. I've got theta 1. And then I've got theta 2. So I'm labeling it, in labeling them on my picture, I'm kind of defining them. So I know which one you're talking about when you talk about them over here. So I've got theta sub 1. That's going to be the one in the T quadrant. And remember here, I'm talking about cutting my triangle into 6 sections on the top, and then I went 1 pi by 6 past that. So there's 6 sections on the top, plus 1 more here, that's 7 pi by 6 sections. And then theta 2, this is kind of like an or, right? I'm not really sure what theta was, but it's one of these two. For theta 2, I'm thinking about there were 6 sections on the top, 6 sections on the bottom, but I'm missing 1 pi by 6 here. So there were 12 sections in the whole circle. I'm missing 1, so that means that there's 11 pi by 6 sections to get to theta 2. And we're all done that question. All right, the third example, given a point, find the angle. So we're given the point 4, -5. It lies on the terminal arm of the angle theta in standard position. Calculate the radian value of the angle if theta is in the interval 0 to 2 pi, round to the nearest hundredth. So there's a lot going on here. Like, what? So let's just start by drawing a picture. It's like what we always do. So I'm going to draw my 2 axes, and then I'm just going to draw this point on there. They gave me this point, and they said go over to 4 and go down to -5 and put a point. And they're saying this point is on the terminal arm. So I'm going to draw in my terminal arm. So there I am. There's my terminal arm. This time I'm only in one quadrant. So it's kind of like starting off with the last one, right? But this time I'm only in one quadrant. The point forced me to be in this quadrant. I'm going to try to figure out first my beta, and then I'm going to try and figure out my theta. So I'm going to take my terminal arm, my point, I'm going to drop it to the x-axis to create a 90-degree triangle. There's my 90-degree triangle. There's my beta. Now remember that if I know that the base here, or the adjacent of this triangle, is 4, and I know that the height of this triangle is 5, or you can think of it as -5 if you want, because I'm talking about beta, a related acute angle. I'm going to use the length of the side of the triangle, so it's a positive number. And then I can also label my theta on my picture. It's this rotation here, because they told me that theta was in standard position, starting at the positive x-axis and rotating counterclockwise. All right, so I know that I've got the opposite and the adjacent. I don't know anything about the hypotenuse. I could figure it out using the Pythagorean theorem, but I don't want to waste my time. I've got opposite, I've got adjacent, that's the tan ratio. So I'm going to use tan for this question. And I know that tan of beta is the opposite over the hypotenuse. So it's 5/4. And then I can actually figure out what beta is. Now notice in this question that they told me I can round to the nearest hundredth. So that tells me I'm allowed to use decimals for this question. I don't have to use special triangles, and 5/4 is not a special triangle. So how do we change this into an angle? Maybe you remember that to solve for an angle, you bring the tan to the other side and do the inverse. So tan inverse, and then 5/4 in brackets. Or you can change that to a decimal in this case because it comes out to an exact decimal. And then I'm going to type that into my calculator. Now, with trigonometry, it's really important that you don't round in the middle of the question. It will drastically change your answer in certain operations. So I'm going to type that into my calculator exactly using 5/4, and I'm going to write down all the decimal places because I'm not done. All right, now that I know the angle beta, I can actually figure out the angle theta. So remember, this is the value of beta. It makes sense that beta is about 0.89. Remember that there's pi radians on the top. So that means that there's 3.14 radians on the top. And we can see here that beta, like my picture's not drawn exactly, but you can kind of see that beta is less than half of, so less than half of 3.14. So that makes sense that it's 0.89. So to find theta, what I'm going to think about is the fact that I have a whole circle, but I'm missing this beta wedge. So a whole circle in radians is 2 pi. Remember, a pi on the top and a pi on the bottom. And then I'm missing the beta wedge. I'm not going to copy out that decimal. I'm just going to use my variable and save myself some time. But I'm typing into my calculator the whole thing. Now, because this is my last step, I can round here. It's asking me for the nearest hundredth. So I'm going to round to 2 decimal places. So I'm typing this in as 2 times my pi button on the calculator and then subtracting this decimal. And hopefully you know how to use your answer button on your calculator. It'll save you some time. And that comes out to about 5.39. All right, enjoy that homework. Happy learning.